it's okay, just make some noise and I can respond, because I don't see you. So, but I think I can hear you. So that would be great. So I'm Arend Koekoek, CEO of Pixelfarming Robotics. Behind the camera is Leslie, who's doing the shooting. You won't see maybe a hand every now and then. Yeah, that's Leslie. And then there's Cindy, doing the branding, and you've probably all had contact with her in getting into this session. So we will be joining you outside. There will be Nico and there will be Jens driving 2 robots. We will be hosting you today. So behind me, you see Robot One 2023 edition. I think it looks very good. It's a closed format machine, similar to the old Robot One. Solar powered. The solar is running really well today because it's nice and sunny down here in Almkerk. Still 4 robotic arms on the inside, still 4-wheel driven, still 4-wheel powered, running up to 3.5 kilometers per hour, processing roughly 1 hectare per hour when you're running it on top speed. Intended to keep your plants healthy by removing weeds, basically, or removing competing plants around it. So that's what this machine is doing. As you can see, it has some scanning technology to see the plants, and it has the 10 arms to do the actions around the plants. And I think down here there's a scheme. So this is the machine. It's can run in different formats, on different bedding sizes. So down here you see the format where it's running on a 3.50 meters wheel distance, which means you can typically run on plants with 50 centimeters row width, or 75 centimeter row width. 60 centimeters is also a format I've recently encountered in, I believe it was what's Prey?
Leek.
In Leek. Yeah. So, but you can also turn the wheels, and down here you see that it's one wheel is on the inside, the other one's on the outside, and then you have a bed size of 3.30 meters, which you can run on. You can also do both wheels on the inside, and I think that's the demo which we're going to show today. Then you end up with a bed size of roughly 2.85 meters, work bed 3.10 meters between the wheels. Of course, you can also run it in the length mode, as we like to call it. It's you can do it for transportation on the truck. You can also use it to run on beds which are smaller. So you have the outside configuration, 2.20 meters wheel distance. You have the one inside, one on the outside. Then you have the 2-meter beds, and then you have both on the inside. You run on 1.80 meter beds. The advantage of this way is that you have 5, because you have the 5 arms behind each other. You have you can on a smaller bed width, you can do more actions on one row of plants. Can be convenient for certain configurations. We're not going to look at this configuration today. We're going to look at this configuration. I'm going to look at it with the laser option. Now, as with the last Robot One, this is again with this Robot One, the tools that are underneath it, you can easily change them or modify them. So you can put the CO2 laser module on it. You can still put a streamer on it, or you can put a rotary tool on it when you want to go into the soil. And maybe there's time I can show you the way that works. You'll see it in the videos as well later on how that works. You can also attach an elbow. I don't know if we have one down there. Yeah, we have one down there. I'll show it later to you, which is basically like with your arm. And that way you can move around the plant while driving forward, which is convenient because when you stay driving, you'll end up with a more stable motion of the machine. So what do you do once you know your plant size? You entered it. What you can do, this is the easy one. When you, for example, have a hoe, you simply use the hose to go in between the plants, in between the rows, as you would do traditionally. This is something you can do, and you will have the advantage of having the data into the system, and then automatically position the heads exactly to the rows, enabling you to hoe very closely to the plant. You'll see something like that in the video as well. But what you can also do is you can basically have the head move around the plant in a sling pattern, like so. That way, you can remove weeds in the row. What the system does, it actually records the individual plant location into the database real time. So while driving, it records the locations and modifies them, and then moves the tool that you have mounted underneath the machine, moves it around the plant, and that way removing any weeds that are in row, and also a little bit in between the rows around the plant. So you can configure different patterns for this, and maybe we'll get to that subject when you're having questions or when we're having discussion rounds. So I think that roughly. Oh no, I'm not there yet. The most exciting parts is the location targeting. When you have trained the machine properly, it will recognize plants, individual plants. And what you can do is you can target each plant individually. So for example, you can train it to see a weed and then decide to burn that weed using the laser module. So while driving, it targets the laser at the plant and then burns it away using the laser. You can also do that with a gripper to pull it out, or you can use the rotary tool to basically drill it away. Might be something which you use with a thistle or with a bigger weed which you want to attack with a bigger tool. I hope you'll get some questions later on that tool. Then I can show you the way it works. So that's roughly what we're going to do. I think you'll have some questions with how it's going to recognize the plant, how it's going to know where the location of the plants are. So that's what we do in the two-step way we work with Robot 1. First, we have the scan action, and then we have the act part.
Manual weeding is a time-consuming, labor-intensive, and physically demanding task. A skilled workforce incurs substantial labor costs and is hard to find these days. To reduce manual labor, you can use Robot 1 to remove weeds with a process we call scan and act. You start your season by sowing your crop as you normally would, and keep the first 100 meters, or about 500 individual plants, weed-free and in optimal condition. This is reference for Robot 1, as it learns from your example. When scanning the soil, it sees what plants you removed and what plants you keep as your crop. As the plants grow during the season, so does Robot 1's understanding of your plant variation. Robot 1 generates a GPS map of individual plant locations and updates this map every run. You can decide to use streamers for in-row weeding, or lasers for pinpoint accurate application. Scan and act with Robot 1. Step 1. You sow your crop as you normally would. Step 2. You keep a small reference plot in optimal condition. Step 3. Robot 1 learns from your example. Step 4. Robot 1 scans the soil. Step 5. You decide what tool to use and what action to take, on a hit or avoid basis. Step 6. Let Robot 1 do the rest.
That's roughly the way scan and act works. So first we scan where the plants are, and then we put an action to what you want done around that plant. It's as simple as that. So the way that it works, so you drive the robot around the field, and we're going to show it in live in real time like that. What it sees is it sees these plants through the cameras that are there. It has a planting line which comes from your seeding system, where it can expect the plants, where it can expect to find plant, and it uses that knowledge to be more accurate about what plants to save and what plant to remove. That way you can teach Robot 1 which plants are there in a very simple way. Because what you do, what it can do is it can recognize that there's a plant and this is the soil. It knows that difference. And then because you keep it clean, you know that there's only one plant type at that location. So all the plants in that location are the type you want to, basically you want to grow, you want to keep. So all the other plants have to go. So what you do, you scan a clean part, make sure the robot knows what that plant is, record the location where the plants are, and then you can keep that database of recorded plant location during the season, because plants don't have feet. They stay at the same location. They just grow. So it can make a growing mask around the plant. Yeah. So what happens? We just did a scanning action. This is what the robot records. So we're looking inside the brain of the robot, what it has seen. Because it's all the same plant, we know that in this case, this is what was in celeriac. In this particular case, you know that each plant that it detects is actually a celeriac. So you can simply store it as a celeriac plant. After this, it knows what a celeriac looks like.
How close can you get to a plant without damaging it?
Yeah, it's a good question. Using what tool? If you want to have, it really depends on the structure of the plant and the tool you're going to use. You can imagine if you have a mechanical tool which does things in the soil, like the rotary tool, it can go into like 6 centimeters into the soil. You would damage the root system of the plant. So then you would not go too close. With the laser, you can get up to technically millimeter area. What we see our customers do is that they go anywhere near like a centimeter in the area, in the vicinity of the plant. So and we would also recommend to do something like that. Start with a little bit more distance till you're comfortable with what the machine is doing, and then you can move closer to the plant. When you look at the vision part, because that's really what's determining the distance that you can get there, and what you see down here, it's actually this. You're talking sub-millimeter resolution imagery. So the location, the way it records locations, is in the millimeter area. So end up with this. The closest distance you could get to it would be something like 1 millimeter in theory. You'd have to be very careful when you do it like that. Is this an answer to the question? Yeah.
Yeah, it is.
Right. Cool. So we move on to the next part. Oh yeah. So the way that works, you have to explain the machine the class of the plant. A classification is typically a phenotyping, a biological thing to understand what class of plant you're dealing with. It's not just a plant; it's a specific plant. So in this case, you just the machine itself already knows the plant from the soil, so you don't have to bother about that part. You just have to tell, you see this plant down here. This is a celeriac. In this case, we use the Dutch name knolselderij. but you can basically name it any way you want it named. And the robot will start talking your language, basically. So when you do it like that, it will start to, once you give him more examples, it will know more of them. And the funny part with this machine is you don't have to drag or label each plant individually using a tool, but you can simply just say this plant is a celeriac, and that plant is not a celeriac, it's something else. So it's very easy to label a lot of images. So the way that works, and you see that in the next part of the video that you see down here. What you see, because you need roughly 500 examples. In this case, a celeriac, for robot AI basically to understand celeriac as a different plant as a plant. And the funny part is with the engine, you can easily gather 500 individuals in this way, because it simply, what you do is you clean the field, you only put celeriac on it. So every plant that's down there is a celeriac. You scan it, and then you have this database, and you just have to validate the images, basically do a quality control to confirm that the machine has the right way. Actually, this is the way you would look under the hood and maintain a Robot One image recognition system. So you can actually see in the brain of this robot the way that machine sees your plants, just like you would do with a normal engine, where you would open the hood, look at the cylinders, and maintain the oil level, etc. And this is the way you would maintain a vision module of a Robot One, just by looking at the images and removing the ones you don't like, or saying, well, I want to improve these images, so I'm going to do an extra patch of celeriac in this case, scan them and add them to the library. That way, constantly improving your computer vision, but remembering the bias that you give the machine. This is a video where we can see the way that works. What you basically do is you draw a field where you say, that's where I want to scan with the robot. And then you can see where it actually run. I have to say it like that. This was an area of field where it has been running, where there were plants, and you see on the screen, you see the plants recorded, the images recorded by the robot, positioned to the GPS. And then what you also see is the black dots. That's where the plants are located according to the data from the seeding machine. And what you see is that they were off. The location was not exact. That's always a problem with these GPS systems and the different manufacturing systems. They're not entirely correct. What you can easily do with this system is basically correct them as you go. And of course, you can use the AI to train it to do this, because basically that's what the AI does as well in real time. But with this system, you can check it, just like you would do with a new employee. You would check to see where he's doing the right thing. This is something we did with Robot One. We made sure you were able to maintain the locations and that you can actually correct what it's seeing yourself before it's actually damaging your plants. So yeah, we're gonna go through it this way. Down here you see some older version, which is nice maybe to see. This is the 2020 version of Robot One, which was the first one. Very open system, a lot of interesting improvements had to be made to this machine. So this is the 21 version of the machine, still an open version, but a lot of things already improved mechanically to get further on. This one is running on the field as well right now. And then we're going to go outside. Over there, you'll see a Robot One running, doing the plant line way of processing. And the guys are looking around to see
We need te ver weglopen.
what he's doing, and he's using the rotary tool to process the lines. And we'll walk down there later on, maybe to see closely what it's doing. I think that's nice to see. Let's look at the laser action, because I think that's where we are here for. This is one of the fields you've been seeing on the scans. So you saw the plants going underneath the robot one, which were recorded in the video. And down here, there's a field of, we name it Ramanas. And what we're doing is we're using the laser heads, and that's by the way, that's Nico, the cool operator of this robot one, making sure that I'm safe around this, because normally the machine would now stop because I'm way too close to be doing this, what I'm doing right now. This machine is running the laser. What's happening down here, and at the left one, you can see it nicely. You see that it recognizes where the Ramanas is, and in between, you see the smoke. That's where the laser is burning, and sometimes you see a little bit of lighting. When the plant is there, it stops burning, and once it has skipped the plant, it turns on the laser, and it starts burning everything that's down there, and it's doing that in a band. But what it's doing is I have to be careful with my hand. It's burning this band. You can of course change that. So what it's doing is it's looking at where the plant line is, moving the head a little bit and moving the laser a little bit in between the plants, and then we're in there. Yeah, and what you can see now is what is happening, because if you were wondering, I don't see anything. It's a CO2 laser. Laat je me verstaan, Nico? Right. It's a CO2 laser. CO2, you don't see that. It's not in the visible light area, but it is very effective on water and water substance plants. And we've seen several examples of that. And you can see, for example, Carbon Robotics is doing the same thing with their CO2-based machine. We use the same technology, and what you see is that it actually works. In this case, we're burning, and the red stuff is glowing. And I can assure you, everything that's down there is dead.
Yes.
The question was, how many images do you need to get to a certain level of accuracy? I believe.
Yeah.
Well, what you
Right.
see, you need roughly 500 individuals, 500 individual plants to get a proper recognition. So to give a feeling on that, this means that when you have a planting distance of, let's say, 50 centimeters, then you scan roughly 10 plants per meter with one machine, which means you would have to run 50 meters of one crop to record enough plants, enough images to get a proper accuracy. So of course, when you look at this field that you see down here, maybe Leslie can show around, these patches are too small. So when you see the fennel down here, it's just 2, 4, 6, 8, 10 times 5 is 50 individual fennels. That's not enough. You'll need 10 of these patches of fennel to train the robot to recognize fennel in this stage in a proper manner.
Okay. And do you have to adjust it depending on the stage of growth?
Yeah. Yes, you do. Just like because it's the fennel in a baby stage, like the two-leaf stage, is very different from the fennel in this stage that you were seeing. So you really have to train it in the different stages, of course. And there is some range where you can when it looks very much the same, but it's really like you have to know when you see it yourself, you have to see that it's the same plant. So when you go from 2-day stage to 6-7-day stage, you can use the same image, and probably when you're in the later stages, like this stage, you can probably use it for like 4 to 5 weeks, something like that in the difference. But you'll need to train it basically in the age that you want to process it. So yeah, that's what we're doing. And then the funny part, it's not that difficult. The way we did it is what you see with a scan action. Is you just run it, and then it already recognizes the plants individually, so it's already puts to the side. So making a model, yeah, it's like what you saw in the video. It's that simple. It takes 1 or 2 hours. Then you do the training run. The training run depends on the size of your database or your model. It can be anywhere from 2-hour training to an 8-hour training session on the machine. So in reality, if you would want to be accurate, you would record, scan on one day, process, and then run it the next day. That's the type of speed. So you don't need to train now for the next season. It can remember it. You might reuse it for next season, but you don't need to. You can go right ahead.
Yeah, okay. So you have to sit at the office and tag images all day.
If you love that. um, no, it's yeah, depending on what it's all day. Um, you'll have to confirm it. That's true. So but it's the amount of work outside is like this. Then you have to confirm the quality, and I would recommend you to do that inside. You can take your laptop and do it outside, but it's so you have to think of an office work like 2 hours. 2 hours of work, and then the training is done by the machine itself. It's like learning French. You just have to repeat the words. That's basically what training is for robot one. So what you just give in the sheets takes you 2 hours, and then the robot will do 6 hours of repeating the words and trying to remember it. That's roughly what the training is like. What is funny though, then when you could do it manually, so you could also do the training and already prepare manually where the plant locations are from your GPS data that you have. It will take you time, but weeding using a mouse is not so heavy as weeding by hand. And also the amount of walking that you have to do to weed a field of 1 hectare, it's zero. When you do digital weeding, you just do it digitally. It can be done anywhere. It can be done, in fact, from any country. You could outsource digital weeding in a low wages country like Africa. So it's a very interesting way of removing the work from field outside where it's hard to get manual labor to the inside where it's easier to get manual labor from anywhere around the world, and keep the low costs. And the technical action is done using the act function of the robot. Does that make sense? The way down here it works is it recognizes the plant, but this is what we call the miss action, so or the avoid action. So in this case, what it does is it keeps on the tool or keeps on the laser in this case, burns away everything that's in the line, and then avoids the plant. And that way, even when it doesn't know the type of weeds, you don't have to train it. It just removes everything in between your crops. Of course, you have to use a smaller plant size when you use the laser in this manner, because the amount of energy you need to burn a big plant is a lot. So if you have big weeds, I would not recommend using the laser, but I would recommend use the different tool, which we're gonna be viewing later on. But when you have very small weeds, then you use the laser. Another thing is with this laser is that when you think I'm just killing off everything right away, it's going up into smoke and I'm done with it, it doesn't work like that either. You might feel like it, but the way it works is basically you sunburn the plant a couple of times and you keep doing that, and that way you suppress it. So you don't burn it all at once, because then you would be driving really slow. And this is an example where we try to produce the steam while driving to show you a bit of a feeling on how the laser works. But in reality, you probably want to drive a bit faster, basically having a little bit lower dosage of laser, but doing that multiple times. And that way you keep the weed pressure low. So if this is everything right now, you can come back later. We're gonna walk to the other side, to the other robot, if that's okay. You can come back.
I don't think you have the connection for that. I'm not sure.
All right, so I'm gonna go back into this area. We're gonna be seeing you see it driving down there. Let's do it like that. Yeah, down there you see the robot just changing lanes from one lane to the next lane, and then driving backwards onto the lane. So what it does is it doesn't turn; it can just stay in the same direction and drive back. So that's a arrow-shaped driving. I think right now it's moving in a relatively medium speed. What you see down there, it can move a bit faster like this. But this one, and this way, what you see down here driving, it'll probably do 0.6 hectares to 2.7 hectares per hour in this speed. Also, what's interesting maybe is, it's nice and sunny. What you see happening right now is that it will, when with the way they were running the machine down there, it'll roughly, it will run all day on one charge due to the sun. This is just June, just the Netherlands. No, it's not even June, it's still May. So you have enough solar power to run a machine basically. You could increase the battery size, we could increase the solar power a little bit. That gives you an indication on what it looks like when the machine runs on solar power.
Yeah, so you can also, it's just sun powered also when using the laser.
Yeah, what you saw down here when you use laser, and I don't know how much power it's using. Can you see that, Nico? Yeah, so it's using roughly 1 or 2 kilowatts right now with what you saw on the mode. There's roughly 30 kilowatt hours on board, which means on this setup you would be able to run so 2 kilowatts. So what is it? So basically 12 kilowatt hours divided by 2, so it's 6 hours. So you could run this on roughly 4 to 6 hours on this battery pack size. Now the funny part with the machine on this, can you hold these packs? These are the battery packs on this machine. You can just unplug them and swap them. So what you would do if you want to be really fast operating, you would just have a spare set of these, and then once it's empty, you just unplug this one, put in the new one, be on your way again. That's the fastest way to keep moving with this machine. Another way is to use the induction charger, a Wi-Fi induction charger. You can just slide in the plate to charge it, or have the robot drive itself towards the plate. Then it would take some time to charge it. You could charge it with the big charger. You would end up charging like an hour and be on your way again. But I think the fastest way is to swap the battery. So that's roughly what you see down here. Okay, let's go back inside, I think. Oh, down there you see again, you'll see the motion again. In this case, it's turning. It has a turning motion to change lanes. So you see it driving sideways, then move like that to the next lane. So there's multiple ways to switch lanes from one lane to the next. And the nice way of changing lanes like this is that the tools that are underneath it are actually in the driving direction. Now with a laser, it doesn't matter because the laser is omnidirectional. You can basically drive forward and backwards anyways. With the hoe has one cutting side and not cutting side on the other side, so you have to drive one direction with the hoe. So you can basically program it to use different ways of changing lanes. And this was the one where because there's hose and rotary tools on it, so it needs to basically reorient itself and then switch lane and drive to the next one. And like what you see down here with this machine, you don't have to do anything. You can just observe it to confirm quality control and to confirm that you're doing it, that it's doing the thing you want it to do. So that's roughly what you see down here. So when it switches lanes, and it's hard to see from this area, but I don't have a proper connection to walk there. But what it does is when it changes lanes, it pulls up the tool just like a tractor would. And then when it goes into the field, it just basically puts down tools into the soil to be able to perform the action. Now it sounds easy when I'm saying it like that, but everybody knows who's driving that sometimes it can be very hard to do it at exactly the right time. And the funny part with the robot is you can do this at, now I love to say millimeter precision, but I think in reality it's like a centimeter precision to move down the tools in that way. But you can be very accurate with it. All right, let's go inside. What if the field is in the rectangle? Let's go there. The way it works, typically, currently we're using straight lines, which would drive straight beds. You can program it to do any curvature, but we didn't do it yet. There's no farmers within our program, and Cindy's going to talk a little bit about the onboarding program later on. We don't have them in our program right now. So the machine can do basically any shape, but yeah, farmer has to use it to confirm that it's working properly. So that's the real story. With regards to the outside contours of a field, you can basically use any shape you like. It's like an outline, which is basically a geofence. Basically, what you can do is you can fill in the geofence with these seeding patterns or line patterns, as you'd like to call it. So the outside shape isn't limited to rectangular; can basically be any shape. Is that an answer to the question?
Yeah, I think so.
Yeah. If not, we can go into detail later on. All right. So you have the video.
What if the rows are not straight? Does it then move the hoe to the side so that it fits?
Yeah. I'll talk about it. You try to find the video.
Yeah.
What it does, it uses computer vision to see where the plants are. So whether or not they are in a straight line, the robot really doesn't care. So either if they're in a curvy line, what it will do is what you saw it do by manually shifting the plant patterns. That's what it will do by itself. So basically what it will do is we'll see the plant is exactly down there or exactly down there, then moves the plant location to where it is. So if you would, for example, which we have, for example, with dahlias, one of our flower growers, they put them in by hand. So what they say is that the plants are in 50 centimeters apart in planting, and they are 70 centimeters apart in the row. In reality, they are anywhere between 45 and 55 centimeters row widths, and the plants are anywhere between 10 centimeters and 20 centimeters apart. So what the robot will do during the scan action is it will basically move the plant, and when it sees, well, it sees this one is at 10 centimeters and that one is at 20 centimeters, it just moves the GPS location, puts it in a database, and remembers that. So that's the way it then runs through this basically jiggly field, and it doesn't care. It doesn't matter. It doesn't matter to the system where they are exactly. So we know lines are never straight because plants don't follow mathematical patterns. They're biological things. So we know they will not be at the exact location. So that's the way we process it. I'm going to share it to see what we. So what you see down here is the rotary tool with a cutting action inside the soil. This tool can go roughly 7 centimeters deep. And the funny part is, normally you would use a hoe, but when you use a hoe with a vehicle that's driving 3.5 kilometers per hour, you need to sharpen the hoe very often because you need the cutting action. So that's one problem. So what we do down here is basically we put the hose on a stick and we make the motion with the head, and that way we do the same cutting thing, but with a rotary tool. We don't have to drive so fast. We can be very accurate around the plant and basically remove the weeds or process it the way we want to do it. So that's what you see down here is basically the way it does it. So it goes very closely to the plant and keeps the plant intact, but doing quite a lot of processing down there. Of course, you can do less if you would want to, but you don't need to. The nice thing with this tool is that you can do process a little bit bigger weeds. So you can do the small weeds using a laser. You can do the bigger weeds using a rotary tool. Of course, you can still use a hoe if you want to, but this thing has a more processing capacity, has more flexibility actually when you use it like that. So that's a nice thing about the rotary tool. I think the next one, is there a question or?
No, not yet.
So I think maybe it's time to talk about if you want one, how does that work? And this is the cue for Cindy, I think.
If you want a robot, we kindly invite you to join our onboarding program because during the onboarding program, we will teach you how to work with Robot One and make sure it will be a success. Having it as a co-worker on your farm. So what you should do is let me know if you are interested, and I'll make sure you have a quotation. We have an onboarding special this autumn. It's just an informatics session where you can join live or you could join online. And then in the last week of December, we will organize an international onboarding week. And you might even become a Pixelfarming Robotics hub in your country in the future.
So if you have more questions or you want to see something, this is a good time. This is a good time to ask us, and basically, yeah, let us know what we can show you again.
But any question you have to do by voice because I'm away.
The cameraman is rocking. If there's something that's in the chat or you want to use the audio, feel free. Are there weeds that we cannot get rid of? I think there's always weeds you can't get rid of. For example, when you have a big plant, largely grown, and it's the weeds are underneath the leaves, and you didn't do a scan action in front before it, so we don't know the root of the plant, then it will be hard. So that's one point where you have to be careful with the system. But I think that's in general the case, and I also think that the plant, the weed that's underneath it, doesn't get any light, so it will be hard. That's the one. Another thing that's hard when you didn't train it and you have the small weeds in the 2-leaf stage or 1-leaf stage, they're looking very much like the original crop, then it can be very hard. This is something like you have with spinach in a full field application, or you have randomly non-located seeding. Let's say onions, planting onions, we just spread around the bed, and to determine them from grasses will be hard. So there, yes, there is weeds which are hard to get, but with proper training, when you can see it, the machine can be taught to see it. You just have to take care to carefully train it to be accurate. So that's a nice thing with the training is that there's a tulip grower in the Netherlands already, and he's detecting diseases. Funny part is when you do a scan action during the season, you might, as a human, not fully see that the plant is developing disease. But because we do a scanning trail and we locate each plant individually, you might see in the end that a plant is getting sick. You could track back on the scanning location, say, oh, that plant looked sick already 3 weeks ago. Basically, you can train a model to have the robots see the disease earlier in a way that you normally didn't see it. So that's a very interesting way to use the scan technology to go beyond just weeds and also go to fungicides and pesticides as well.
Okay.
So I think
we're done.
This is the part where we're in the group. We're done. If you want to know more or contact us personally, that would be easier. We'd be happy to take you through these things in detail with your particular system or with your particular country to see how we can move forward. There's a couple of programs we're setting up with the Dutch government. So there's a lot of things going on. Reach out and we'll help you. So my name is Arend Koekoek. I'm from Pixelfarming Robotics, and I hope to see you somewhere in this lovely world. Thank you.
Thank you.